Okay, so now we're going to be looking at how to do within participants test, t-test. This is also called the paired samples t-test. Paired samples because each person is paired with themselves. Again, looking at the data here, remembering the little rule that these are participants down the rows and the columns are variables or measures taken of that participant. We can see that this is within participant design because participant 1 is being measured more than once, twice. And these two variables, structured and informal, what this relates to is a piece of research in which an educational researcher was interested in which particular teaching method was most useful for students. So what she did was to give participants a structured teaching session, and afterwards she measured their IQ, and then sometime at a later date the same participant was given an informal teaching method and their IQ was measured again. So each person was measured twice, which gives us a wholly within participants design here. So what we would do normally when we do this, we would test for skewness first of all, and test for outliers to make sure that it is appropriate to use a t-test, or to determine which test we should use. Should we use a t-test or should we do something else? We can have a quick go at that if you like. The various different ways of getting these data, but I find the easiest way to get the skewness statistic is to do frequencies here. We have structured versus informal, so that both of those are the DVs, so we put them both in. We can get a chart, so let's ask for a histogram, let's ask for a normal curve on a histogram, continue. Let's go to statistics, let's ask for the mean, the median, the standard deviation, the range. So we've got both parametric style statistics here, the mean and the standard deviation, and non-parametric measurements, the median and the range here as well. And also we'll ask for skewness. So we click OK, and then OK again. Get a load of junk thrown out of us here, but remember the one test for skewness is to see whether the skewness statistic here is greater than 1.96 the standard error of skewness. So if this skewness statistic is bigger than that, so bigger than almost twice the size of the standard error for skewness, then we say this data is significantly skewed. And you can see here this number, skewness, in neither case is it twice as big as this. Okay, so you can either multiply 0.66 by 1.96 and see if that's bigger than 0.144, but it's pretty obvious that it isn't. Again, ignore the minuses here. These just tell you whether the data are slightly negatively skewed or positively skewed. And in both of these cases, the data aren't significantly skewed. We've also got a histogram here, which we possibly should have looked at first, and you can see the data are very, very normal looking with a nice kind of bell curve here. But the crucial thing is whether these data here. We've also got the means for each of the two groups, the medians, the standard deviations, and the range at the bottom here. It's 11 in both cases. Okay, so let's go back to our data. We can see that these meet parametric assumptions. Then the test was an IQ test, which is either interval or ratio. Difficult to say what 0 IQ means. The 0 mean no intelligence whatsoever. Hard to say that. Probably it doesn't mean that. So we can say that that's at least interval, but that's okay if we're doing a t-test, which is what we'll do. So what we're looking for here is to go to analyze, and we're looking for, again, to compare means. We find here the paired samples t-test. Right. Sometimes people get confused and go for the one sample t-test because they think that means it's within participants. No, that's not true. It's the paired sample because each person is paired up with each other. So let's go back here. Now we've got no coding variables to deal with or anything because it's purely within participants. So all we do here, we've got variable 1, variable 2, pair 1. We simply move whichever way around you want to do it, structured into variable 1 and informal into variable 2. None of these options do anything particularly helpful at this stage, so we'll just go OK. And what we get here is the output. So the top one here just gives us, as we've already seen, the means and the standard deviations, because that's the appropriate measure of central tendency when we're dealing with parametric statistics. This doesn't tell you particularly anything interesting in the paired samples correlation, so ignore that and ignore that significance level there. The crucial one is the one at the bottom here, and we read across and we find we have a t-value of 3.9, rounding up, and a significance level of 0.003. So we would say that this is significant. This is a fairly significant finding that we have here. We might then want to go on and measure the effect size, but SPSS isn't very good at measuring the effect size. So if you look on the website, under the effect size menu, there's a link to a website in which you simply enter some of the information from the SPSS outputs, and it will give you a measure of effect size using something like Cohen's d. You can request different ones, but that's the easiest way to do it. The only other way to do it would be by hand, which you're perfectly welcome to do, but I just suggest you use the website.